हेलो एवरीवन। सभी का स्वागत है मेरे इस यूट्यूब चैनल पर। आज हम लोग 11th क्लास की मैथमेटिक्स की क्लास स्टार्ट करेंगे और अकॉर्डिंग टू द सिलेबस ऑफ द सीबीएसई बोर्ड एंड यूपी बोर्ड सिलेबस, द फर्स्ट चैप्टर is the set theory. The first chapter from the syllabus is set theory. So आज हम लोग सेट थ्योरी का चैप्टर जो है वो स्टार्ट करेंगे। तो सेट थ्योरी को समझने से पहले हमें कुछ स्टैंडर्ड जो नंबर सिस्टम्स हैं उनके बारे में जानना होगा। सो कुछ नंबर सिस्टम के बारे में हम लोग जान लेते हैं। ओके, सो बेसिकली अगर हम नंबर सिस्टम की बात करें तो हम स्टार्ट करेंगे इसको नेचुरल नंबर के साथ। The set of natural numbers is denoted by the capital N, it's like this, and this collection of natural number contains the numbers from 1, 2, 3, 4, and up to infinity. So if we have a collection of the numbers like 1, 2, 3, 4, we will give it a name of the this collection is known as the natural numbers. Now the second one is as whole numbers. So if we include the zero, in the set of natural numbers, we include the zero in the set of natural numbers, this collection becomes the whole numbers. Okay. After this, we have the integers. So the set of integers is denoted by either I or by Z, and it is denoted by Z, and it contains the numbers from minus infinity. It's minus 1, 0, 1, 2, and up to infinity. Okay, and the set of rational numbers. The set of rational numbers. The set of rational numbers is denoted by actually Q, and it contains the number of the form P upon Q, where the P and Q belongs to integers. P and Q belongs to integers such that this Q must be non-zero. After this, we have the set of real numbers. Okay, the set of real numbers contains the combination of rationals and irrationals. Hope all the students are familiar with the irrationals, as you have seen in your 10th class syllabus. So the real number is actually the set of real numbers is actually the combination of rationals and irrationals. Okay, if we include all rationals and irrationals together, we got the collection, and this collection is known as the real numbers. And after this, we have the set of complex numbers. So in the set of complex numbers, we forget here the set of real numbers is actually denoted by R. Okay, it actually denoted by R, and the set of complex number is denoted by C. It contains the number of the form A plus IB. Okay, where A and B both are from the real numbers. By this I we have we call this I as iota, and this part of this complex number is known as the uh, imaginary part of the complex number. So this is the real part of the complex number, and this is the imaginary part of the complex set theory. Okay. So first we will see the definition of this set. Definition of a set. A set is actually a well-defined collection of the objects, things, or uh, numbers. Okay, a set is actually the collection of the well-defined collection of the things, objects, and numbers. Like we can see this with an example. सैंपल के थ्रू हम लोग इसको देखते हैं. सपोज ए हमारे पास एक कलेक्शन है नंबर्स का ए ई आई ओ एंड यू. Okay, by seeing this collection we can say that this is the collection of vowels. Okay, this is the collection of vowels. This means we are able to define this collection. Okay, and if we write this one as a as a b c e I. Okay, so we are not able to define this collection as well. Okay, so we cannot say this collection is a set. If we are able to define a collection in well manner, we will call this collection as a set. Okay, so the definition of set is a well-defined collection. Well-defined collection. Well-defined collection. Simply, a well-defined collection is called a set. Okay. For example, you can see that. For example, as I have written here, A is A E I O U. You can write it. Okay. You can also write this one as A as 1, 3, 5, 7, 9, 11. This is the set of odd numbers, odd natural numbers less than 12 or less or equal to 11. We can define this set as the set collection of odd numbers less than less than 12 or less or equal to 11. So similarly we can define another set like 2, 4, 6, 8, 10. Okay, we can define this set as the collection of even natural number less or equal to 10 or less than 11, like this. And suppose we are writing a set C by 1, 2, 3, 8, 11, and maybe 17 will come here, and so on. So see this set, we are not able to well define this collection. Okay, we are not able to well define this collection. This is the collection of natural numbers, but there is no specific property satisfying by these elements. Okay, so we will call this as a collection of natural numbers, some natural numbers, but we will not call it as set because it doesn't satisfy any specific property, or we are not able to well define this collection. Okay, so we will represent the elements of the set by the small letter of the English alphabet, and the whole set will be represented by the capital letter of the English alphabet. Okay, हम जो सेट के जो एलिमेंट्स हैं उनको हम लोग स्मॉल अल्फ़ाबेट्स इंग्लिश अल्फ़ाबेट से रिप्रेजेंट करेंगे, और जो भी जो हमारा होल सेट होगा उसको हम लोग इंग्लिश के कैपिटल अल्फ़ाबेट से रिप्रेजेंट करेंगे, लाइक वी आर डूइंग हियर ए बी सी, and we will put all the collection in the curly bracket. To represent a set, we will put all the collection in the curly bracket. So a collection of the form like this we have written here is the representation of a set. Okay, so I hope you understand the uh, meaning of set and the way we write or we represent a set. Okay, if we talk about the elements of the set, by the elements we means that the contents in a set. Okay, the numbers, the things, the objects that are contained in the set is called as the element of the set. So if we want to show that any element is either in the set or not in the set, we will represent this one by, if we talk about the set A, 1 is belongs to A. Okay, this is the symbol for is belongs to. Okay, and if we talk about this one, is it doesn't belongs to B, doesn't belong to B. Okay, if you talk about one, it belongs to A and it doesn't belongs to B. Okay, like this if you want to say that in C 5 doesn't belong to C and 8 belongs to C. Okay, like this. So if we want to so that any element is in the set or not in the set, we will use these two symbols. This is for belongs to and this is for not belongs to or doesn't belongs to. Okay, after this we have the different ways to describe our set. So there are two way to represent our set. Okay, so description of a set, so there are two ways to describe a set. The one is the roster form or tabular form. Roster form or tabular form. Okay, and the another one is a set builder form. It is a set builder form. Set builder form. So in the roster form or tabular form, we put all the elements. Of set with one by one and separating them by commas. So suppose we have, for example, we have the set of even numbers, set of even natural numbers less than 10. Okay, less than 10. Then we will write it as 2, 4, 6, 8. So we have the set of even natural number less than 10. So in roster form, we will write this set A as, we will write all the elements of the set in the curly bracket and we will separate the elements by putting comma between them. In set builder form, we will represent our set A. Okay, what is A? A contains the elements X such that this X satisfying the property. Which property? X is an even natural number. Even natural number less than 10. Okay, so in set builder form we express our set with the property of the element that are satisfying. That the elements are satisfying. And in set builder, in roster form or tabular form, we put all the elements one by one and separating them with commas. So अगर हम रोस्टर फॉर्म की बात करें तो हम सारे एलिमेंट्स सेट के सारे एलिमेंट्स को लिख देते हैं और उन्हें सेपरेट कर देते हैं कॉमा के द्वारा. इन सेट बिल्डर फॉर्म हम एलिमेंट्स की जगह उनकी प्रॉपर्टी को लिखते हैं. हम एलिमेंट्स की जगह वन बाय वन सारे एलिमेंट्स को ना लिख करके हम उनकी प्रॉपर्टीज को लिखते हैं. विच प्रॉपर्टी द एलिमेंट्स ऑफ द सेट आर सेटिस्फाइंग. सो जो प्रॉपर्टी एलिमेंट्स सेट से एलिमेंट सेटिस्फाई कर रहे हैं उस प्रॉपर्टी को लिख देंगे तो हमारा सेट बिल्डर फॉर्म बन जाएगा. Why we need these two forms? Because sometimes we have a few elements in the set, so we can easily write the set by writing its element one by one and putting the comma. But sometimes we have lots of elements in the set. Okay, like if we do not restrict ourselves at here, okay, less than 10. अगर हम यहाँ पे लेस देन 10 वाली कंडीशंस को हटा दें, कंडीशन को हटा दें तो हमारे पास ए कैसा सेट है, इवन नेचुरल नंबर्स का सेट है. सो ए विल बी नाउ कैन बी रिटन एज 2 4 6 8. वी आर नॉट एबल टू राइट ऑल एलिमेंट्स हियर बाय सेपरेटिंग कॉमर्स. ओके, वी हैव टू पुट अ डॉट डॉट. we are not able to write all the elements like we have written here in A. So what we will do, it's very good to write here x such that x is an even natural number. Even natural number. So it's very easy to write our set in one line or one statement. If it have a lots of elements in the set. Okay, so these are the difference between these two form. If we have few elements in the set, we can use our tabular form or roster form. If we have lots of elements, so we are not able to write all the elements one by one, so we will use the definition part of the element or the property of the element to represent our set. Okay, so after this we will see the types of sets. Okay, after this we will see the types of set, how many types of sets we are going to study. So types of sets. So if we talk about the types of sets, so the first name comes as the empty set. So this classification of sets is based on the number of elements in the set. Okay, this classification of set is based on the number of elements in the set. So we talk about the types of set. First name comes at empty set. So नाम से ही समझ में आ रहा होगा, empty set का मतलब है कि this set doesn't contain any element. Okay. If we can define it as if a set has no element. If a set has no element. Okay. If a set has no element, it is called as empty set. Okay. It is denoted by 5. It is denoted by 5. Okay. So we also call this empty set as a null set, void set. Okay, we also call this empty set as null set or void set, and we also denote this empty set by the blank curly bracket. We also denote this empty set by the blank curly bracket. If we see an example related to this, for example, okay, A is a set containing the elements x such that x is an even prime even prime and x is greater than 2. So our set is defined as x is an even prime and x is greater than 2. So I क्या ऐसा कोई नंबर इवन प्राइम हमें मिलेगा जो 2 से बड़ा हो, 2 से ग्रेटर हो? सो हम सब जानते हैं कि 2 इज द ओनली even prime. Okay, so there is no prime greater than 2 which is even. Okay, so this set A is actually empty set. We do not have any element in this set. Okay, we can also see that another set we can see the example that x is such that uh, x belongs to natural numbers. Okay, and the value of x lies between 5 and 6. X is a natural number and the value of x lies between 5 and 6. So there is no natural number between 5 and 6, and that's why this B is also an empty set. Okay. After this we have another, this is Singleton set. Singleton set. So by the name you can also understand, by the Singleton set we means that if our set contains only one single element, our set contains only one element, we will call it as Singleton set. So if set contains one element, if set contains one element, is called as Singleton set. Okay, for example you can see that, for example we can see that A is a set of element x such that this x is an even prime. This x is an even prime. So you all know that the only even prime number is 2. Okay, so this A contains a single number, so this A is a Singleton set. Okay, after this Singleton set we have finite set. Finite set. How we will define our finite set? If it has a finite number of elements, or we are able to count the numbers in the given set, or we are able to label the elements of the set with natural numbers. Okay, if we are able to label the elements of the set by the natural numbers 1 2 3 4, okay, and listed by the natural numbers. Okay, so we can define our finite set as a finite set is a set whose elements can be labeled with the set of natural numbers and it terminates at any point or number. By means we can see that I'm writing here an example. It is contains A, B, C, D and up to Z. So as you can see that this is the set of English alphabets. So we can label the elements of this set. This A can be labeled as 1, B can be labeled as 2, C can be labeled as 3, D can be labeled as 4 and Z can be labeled as 26. Okay, so we have started labeling the elements of the set with natural numbers and we have comes up with an end. We have terminated it at we terminated this labeling at some stage. So such type of set is called as finite set. if you have to ask what is a finite set, you have to say that a set is called as finite set if its number can be labeled with the natural number and this labeling terminates at some stage. कुछ नंबर्स के बाद ऐसा हो कि हमारी लेबलिंग जो है वो खत्म हो जाए, मतलब हम उसे completely लेबल कर पाए. Okay, so we can say that this set is a finite set. In the same way, we can define infinite set. Okay, so infinite set, one simple definition is for the finite set is a set which is not finite. A simple definition for infinite set is that a set which is not finite is called as infinite set. Okay, but in the way we have defined our finite set, we can define this infinite set as a set A is called as infinite set if we started labeling the elements of the set with natural numbers and it never comes up with end. मतलब ये है कि अगर हम किसी भी सेट को किसी भी सेट के एलिमेंट्स को नेचुरल नंबर के साथ लेबलिंग करना स्टार्ट करें, we started labeling the elements of the set with natural numbers और हम उसके एंड पॉइंट तक पहुंच ही ना पाए, कभी हम उसके एंड पॉइंट तक कभी पहुंच ही ना पाए, तो हम उसे तो इस तरीके के सेट जो होंगे उसे हम लोग इनफाइनाइट सेट कहेंगे. फॉर एग्जांपल यहाँ पे हम ले लेते हैं 2 4 6 8 10 12 एंड सो ऑन. ओके, so if you start labeling this set with natural number, this is 1, this is 2, this is 3, and this is 4, this is 5, this is 6 and so on. ओके, सो यहाँ पे क्या है कि हम इनके नंबर्स को लेबल कर सकते हैं नेचुरल नंबर के साथ, बट ये जो लेबलिंग है ये कभी भी टर्मिनेट नहीं होगी. दिस विल बी गो अप टू इंफिनिटी. दिस लेबलिंग विल नॉट बी टर्मिनेटेड. So such type of a set is called as infinite set. Okay, and after this we have another cardinal set. Okay, we have cardinal set, cardinal number of a set, cardinal number of a set. So if A is any set having n number of elements, okay, in place of n write this one as p, having p number of elements. Okay, then the cardinality of A is defined as the n of A is equal to p. The cardinality of a set is actually the number of elements that a set contains. If our set contains p number of elements, then the cardinality of this set is actually p. Okay, on the basis of this cardinal number we have two different category of sets. So one of them is as a equivalent set. Equivalent sets. So two sets A and B are called as equivalent if they have same cardinal number. Okay, that means that n of A is equal to n of B. If two sets have same cardinal number, then they are called as equivalent set. For example, we have a set A as 1, 2, 3, 4, 5, and we have another set B as A, E, I, O, U. Okay, so you can see that both set A and B have 5 elements. That is, cardinality of A is 5, as well as the cardinality of B is also 5. So these sets A and B are equivalent sets. Now we have another category of sets is called as equal sets. Two sets A and B are called equal sets if they have same cardinality as well as same elements. With the cardinality, we also have the same elements, then the two sets A and B are called equal sets. For example, we can see that if we have set A as 1, 2, 3, 4, and our B is as 2, 3, 1, 4. So you can see that both the set A and B have same cardinality. That is both sets have 4 elements, and we can also see that the elements in both sets are also same. So if two sets have same cardinality and the same element, then we called it as equal sets. So we can see that every equal sets are equivalent. If two sets are equal, we can say that they are equivalent, but the converse need not be true. But the converse need not be true. अगर कोई भी दो सेट हमारे पास इक्वल सेट्स हैं तो हम ये भी कह सकते हैं कि वो इक्विवेलेंट भी है, बिकॉज अगर इक्वल है तो उनकी कार्डिनलिटी सेम होगी, कार्डिनलिटी सेम है तो इक्विवेलेंट हो गया वो. बट कन्वर्स इसका ट्रू नहीं है, बिकॉज अगर कोई भी दो इक्विवेलेंट सेट है, जैसे कि हमने यहाँ पे देखा इनकी कार्डिनलिटी सेम है बट एलिमेंट सेम नहीं है, दे हैव द डिफरेंट एलिमेंट्स, दे हैव द सेम नंबर ऑफ एलिमेंट्स बट दे हैव डिफरेंट एलिमेंट्स. सो अगर कार्डिनलिटी सेम है बट एलिमेंट सेम नहीं है तो फिर वो इक्वल सेट नहीं होंगे, वो सिर्फ इक्विवेलेंट सेट होंगे. ओके, स्टॉप कहाँ से है, तो वही नहीं रहा.